Hi all, good day everyone. Welcome to Deep Learning series by First Principles. So this is the continuation of the Python Basics part 1. So already we have seen and joining the tensors in various dimensions. Okay, so we have seen dimension 0 and dimension 1. And this one, next one is the arithmetic operation. Basically, arithmetic operation everybody knows. Arithmetic operations are one is addition. Okay, so one is addition or subtraction. Okay, another one is multiplication and division. Okay, so these are the arithmetic operations. Okay, so here we are going to see, so this is the matrix multiplication. So matrix multiplication entirely different from this is the simple element wise multiplication. So already I have given one video. Okay, so matrix multiplication, so please see that video so you can understand how do we do matrix multiplication. Okay, and next, so this way we can use this at operator. Okay, so this way we can do a matrix multiplication. So here next one is so this way I have to same matrix. Okay, same matrix I can multiply with the same matrix. Okay, this is y1, so this is also y2, I multiply with the same matrix. Okay, this is y3. Okay, this one is creating the torch random like. Okay, y1, so y1 matrix same size. Okay, already we have seen random like means the same size as y1 is here. They are creating the same size of the matrix, and but that matrix is a random. Okay, this matrix is a random matrix. Okay, so y3, so now they are multiplying, so matrix multiplication with tensor and tensor t. Okay, so now out value they are storing in the y3. Okay, y3. So if you use out, so already we have to declare. Okay, so if you have to use the out keyword, we have to declare the y3. Okay, it should be existing one. Okay, so this way we can do a matrix multiplication, and these are things are the element wise. Okay, element wise multiplication. Okay, so element wise product. Okay, so this way we can perform a arithmetic operations in the PySpark. Okay, so next we will see single element. Okay, single element tensors. Okay, so now I am going to sum the tensors. Okay, this will sum all the values in the tensor. Okay, so this will give a single value. So if I want to see, this is age is the tensor. Okay, so if I want to this as the number numeric, I have to use the item. Okay, so I have to use, so if I use item, I can see that the output is pure a numeric one. So okay, so I will stop. Okay, so first I have to run tensors. Okay, so here tensor, shift enter. Okay, this is tensors. Okay, tensors are not in torch, is import torch. Okay, okay, so import torch. So then you will see shift enter. Okay, so now I will get the result. Okay, so this way we can convert a tensor to a numeric value. Okay, so next one we will see in place operation. Okay, in place operations, so usually all the functionalities. Okay, all the functionalities, if you use a underscore, it will be a in place one. Okay, so this way we can do a in place functionality copy or anything of underscore t. So this will be a in place. Okay, this will perform a in place operations. Okay, so next we will see next we are going to see a record grade. Okay, so already we have seen a lot of videos about that partial differentiation. Okay, so the partial differentiation and the gradient. Okay, so this way we can see how to we define all these things. Okay, so now we are telling, so because in our value class, okay, analogous to our this tensor object here, okay, that tensor class, where we have used on that value class. Okay, the value class, in that value class, okay, the we didn't, this is not an option. Okay, it will, if you give any operation, anything, whatever we have seen in our example, gra- the gradient is calculated. Okay, but here, if you, we can switch on and switch off, because it take a lot of computation. Already we have seen that already inside the function, again it's calls again the again back propagation. Okay, again the back propagation is a separate function. Okay, there is a separate function. So we have to avoid all those computation types, because if you see, if you, we have to calculate only the gradient for the weights only. So if you see in a computational graph, okay, if you see in a computational graph in our previous one, in our previous video, okay, so in our previous video, if you see Pytorch basic, okay, uh, sorry, not Pytorch basic, okay, this is okay, here we can see Google Colab. Okay, Google Colab. Okay, here we can see. Okay, so this is the computational graph. Okay, so the final one is the computational graph. So here we have to calculate. Okay, we have to calculate this one. Okay, we are not necessary to calculate the gradient for x2, gradient for x1. Okay, all these things are not necessary. Okay, we have to calculate only the gradient for w1 and w2. So in this case we have to use this option. Okay, this option, whether record gradient is this is the record one or not. Okay, so first we will see this is the correct one, then we will go there. Okay, so this is the tensor and record gradients are okay. So then next we will just add. Okay, so this is, we will just add 1. Okay, then we will multiply with the, okay, same value. Okay, squaring the same value. Now we are sum. Okay, now we are sum the value, then we are going backward. Okay, so now we are going backward, then we will see the gradient of all the values. Okay, x and everything, we can see the gradient. Okay, shift enter. This way we can get the gradient in the PyTorch. Okay, so you see here we have enabled. Okay, so we have enabled. Okay, we have enabled record gradient is true. Okay, then we will do a our first operation, so it's equal to x plus 1, then we will squaring it. Okay, then we will sum. Okay, then we will sum all these values. Okay, all these values, then we will back propagate. Okay, then we will do back propagate, then we will show our gradient. Okay, this way we will do. Suppose, okay, so because it in this already we have seen in the previous example, we have seen how to how do we do a inline operation. Okay, so how do we do a inline operation? Suppose this y is equal to x plus 1. If I did this way, okay, if I did this way, y is equal to addition of 1. Okay, y is equal to addition of 1. Okay, here y is equal to x is our this one. Okay, here we are just adding the 1 to our whatever our declared our, this is just one arithmetic operation, we are just adding 1. So same this way, now I am using the in place operation. Okay, so in place operation, finally I run the backward. Okay, backward, finally I will get that x grade and y grade. Suppose if I run this way, I will get this error. Okay, because in the computational graph, okay, so in the computational graph, okay, so in the computational graph already we have seen in the computational graph, okay, in the all these computational, so if you do any inline operation, there is no computational graph, okay, this computational graph will not generate, okay, this computational graph will not generate. So what will happen, so we can't, okay, we can't calculate, okay, we can't calculate these operations, okay, in this operation if you want to calculate what I say, so this is, okay, this is not captured in the computational graph, okay, then we have to calculate each and every step for our gradient, okay, so if you use the gradient true means this step we can't able to calculate our gradient, okay, so the pytorch explicitly tells, okay, so get gradient tensor that is true, okay, the leaf tensor not accessed, okay, because we cannot access this one, this operation, okay, this operation, so the attribute cannot be one be populated doing a autograde backward. So print y dot grade will show in the, okay, you see, we accept y dot grade and we have accept we asked x dot grade, okay, shift to cache, okay, shift to cache, okay, shift enter, shift enter. Now I got x dot grade, I got, okay, suppose, okay, y dot grade, you see, shift enter, y dot grade, I didn't have the value because y dot grade, that is it has the in place, okay, it has the in place operation, okay, so this is the, so we have to take care, okay, so to avoid this type of subtle errors we have to so if you use the gradient, so we don't use the inline operations, okay, so this only we have to take care. So next one is sharing memory, okay, so this is also another interesting concept, okay, because both are sharing the, so if you use the numpy and torch, okay, both are sharing the same memory, okay, so first I will declare torch dot once, okay, so now I will print, then n is equal to, now I convert into n pi, okay, now I will check the both values, okay, now I will check the both values, okay, np is not in okay, so we will see same value, okay, so print, okay, t equal to, this is tensor, okay, this is the tensor, this is the numpy array, both are same value, okay, so both are same value because this is once, okay, this is once, now I am going to add, okay, both are same value because both are converted, now I am going to add one, okay, now I am going to add the tensor, automatically you see the second one is the, now I will command all those things, okay, command, okay, command, okay, command, just shift enter, okay, if you see, okay, this is also we will command, okay, command, sorry, command, okay, if you see, this is our, okay, so this is our if you see, this is our t for tensor, okay, n for numpy, okay, so n for numpy, so we will get same, both are same, okay, but I am adding only the tensors, okay, but what I say, the numpy value also changes because this is the n value, okay, this is the n value, after n value if you print the n value after doing addition to the tensor, because both are sharing the same memory, okay, so next one is np of ones, okay, so again I will command, okay, so this is the next one, same value, okay, np of add, okay, changes in the numpy and reflects in the tensor, okay, shift enter, okay, again if you see same data type, okay, so print okay, so this way this will share the, okay, this will share the memory, Thank you for this video. We will see in our next video. Please subscribe. Don't forget to subscribe, okay? And comment and like